Hey guys, Mr. Milton here. On to our third lesson of the first unit of geometry. We're going to talk about the segment addition postulate today. Okay, at the end of this lesson, you should be able to use the segment addition postulate to find missing segment lengths. Okay. All right, let's jump right into it. The distance between any 2 points. The segment's endpoints. That's what we're talking about when we're talking about 2 points. Is the absolute value of the difference of the corresponding numbers. Okay. In other words, if we're looking at a line segment AB, then we're going to say the absolute value of A minus B, whatever that is, that will give us our distance. Remember, absolute value makes sure that the number is positive, okay? Because when we talk about distance, we only have positive distances. All right. So looking at this first problem, we need to find EF. So we kind of have our skeleton of how we should set this up. And so I have the absolute value of E minus F, or negative 4 minus 8. Okay. And so negative 4 minus 8 gives us negative 12. The absolute value of negative 12 is 12. That's how far apart E and F are. That's the length of that segment. Okay, notice here that there's no symbol above EF. It doesn't say like ray or line or segment. So that indicates that you're finding the measure of that segment. So it's not inconsistency. It just means that we're talking about the actual measurement of that. All right, two segments with the same length are called congruent segments, or they are congruent segments. Geometry has a lot of symbols, and you'll get used to them so that most of them become kind of second nature to you. Congruent is one of those that you'll see a lot throughout the year, and that is just this equal sign with this tilde over top of it. Okay, equal meaning number. This tilde usually means like same shape, so same number, same shape, congruent. Okay, all right. In this diagram down here, you see that there's markings between AM and MB, or BM, and that indicates that those two segments have the same length. So we can say it in a couple different ways. If we're writing a sentence or a statement, we can use this congruent seg. But if we're using just a diagram and I'm not giving you written sentences, then this says, hey, these two segments are the same. Okay, so that means AM, segment AM is congruent to segment BM. Okay. Now, if these two are the same, okay, from AM is the same, from A to M is the same as from B to M, that means M is the midpoint of AB. It's in the middle. So it's a term that you should be able to recognize and use if given in the description or a problem. Alright, so we can do that with values, we can do that without values, and kind of with more algebraic expressions, but let's talk about it on a number line first. So first it says find AB and BD. AB, okay, we'll do that same thing here. We have negative 8 minus negative 5. So negative 8 plus 5 minus a negative is plus, gives us 3. For BD, we have negative 5 and 0. That's kind of a lot easier because how far away are they? It's 5. Remember that distance is always positive. For number 2, it says which segment is 8 units long. Okay, and so you can just look up here. I guess you can count 8 units. Oh, here you go. Negative 8, 0. That's 8 units long. That segment is called AD. Name two pairs of congruent segments. So let's see, two segments that are the same distance from each other. So negative 8 and 5 is 3, negative 5 and 2 is 3. So I can say that AB and BC are congruent. The second pair, those three, these look, so negative 2 and 0, that's 2 away, 0 and 2, that's 2 away. So CD segment CD and segment DE are congruent segments. Okay, so there we go. Oops, a little bit too low for you, but hopefully you heard me, so you know what I wrote. Moving to the next slide. Now we talked about measuring segments and finding their distance, and now let's actually get to the segment addition postulate. Okay, so what the segment addition postulate says is that if 3 points, okay, we'll call them A, B, and C, are collinear, means they lie on the same line, collinear, and B is between A and C, then A plus B, or sorry, AB plus BC equals AC. Okay, and I can give you this picture really quick. Okay, I got 3 points. Doesn't matter how we draw the line or where we put the points, A, B, C. So what this says is this part AB plus this part BC equals the whole thing AC. So if this was 10 and this is 7, 10 plus 7 equals 17. Okay, pretty common sense there. Okay, a lot of these early postulates kind of seem to be that way. But let's make it a little bit more challenging, I guess. For number 1, it says find A, B, and CD. So, number 1, we're given this diagram, and in this diagram they tell us that AD is 54. We can tell by that marking. So AD is 54. We need to find AB. So hold on. AD is 54. BD is 36. So what's this distance here? This distance here has to be the difference between 54 and 36. And that is 18. So AB is 18. Did I do that right? Yes. Okay. Next, we need to find CD. So this is 18, this is 20. So that means that AC is 38. If this whole thing is 54, then 54 minus 38, that difference will be CD. And that's 16. Alright. And last, and probably easier problem, is just find AC. Well, AC is AB plus BC. So 18 plus 20, which is 38. Alright, so not too challenging there. Hopefully you see how to break that down and kind of critically think to get to that answer. We use the segment addition postulate really for all of those, most explicitly for number 2, but even for the ones that we subtracted, we kind of used we assumed that that was true, so we used it. Okay, this next example says find the value of x and show the equation you used. So here we go. For this problem, we're given this diagram, and it's really common, guys, for people to just say, oh, s is in the middle, so 2x minus 8 equals 3x minus 12. That is not the case here. Okay, we could do that if they told us that ds was congruent to st, but they didn't do that. So let's make sure we look at the whole problem. And then for this problem, they told us that dt is 10. So what they're saying is ds plus st equals 10. And that's what our equation is. So ds, 2x minus 8, plus st, 3x minus 12, equals 10. You can solve out that problem. 5x minus 20 equals 10. Add 20 to both sides. 5x equals 30. So x will equal 6. We'll write that down over here. 5x equals 30. X equals 6. Okay. And now they say find ds and st. So now we're actually finding the measures of these segments. And so we'll plug in 6 for for x and see what we get out. So 2 times 6 is 12. 12 minus 8 is 4. For st, 3 times 6 is 18. 18 minus 12 is 6. And we should have this plus this equals this. So 4 plus 6 equals 10. Okay, checks out. Alright, last problem. Or set of problems at least. use the figure to answer the questions. So we have 2x plus 1, 3x minus 4. And now the difference between here is this given told us that dt was 10. For this next problem, they tell us, our given is that c is the midpoint. Okay, midpoint's important for us. What does that tell us? That means it's in the middle, the exact middle. So this is equal to that. And so that's our equation. They didn't give us any other values, but they gave us enough to figure these problems out. And that's one thing that you probably have to think of to yourself, especially during these first few weeks, is they have to give me enough information to solve this problem. Okay, so how can I get to that answer? Okay, and this midpoint gave us enough information. It told us that AC was the same as CV, or 2x plus 1 is equal to 3x minus 4. And now we just solve. So I'm going to subtract 2x from both sides, gives me x. Add 4 to both sides, that gives me 5. X equals 5. They ask me to find AB, and there are a few different ways that we can do that. One way, I can plug 5 in here. Gives me 10 plus 1 is 11. If these two are the same, because C is in the middle, then 11 plus 11 is 22. Or I could do the same thing here. 15 minus 4 is 11, and then add the 2. Again, should still give me 22. Okay, so we talked about using our measuring segments on the number line. Talked about how to do that. Looked at different notations or different ways that we can write equal. Talked about the definition of midpoint. Used all of that along with the segment addition postulate to solve. Okay. All right. See you tomorrow.